The difference in value of acceleration due to gravity at pole and equator is proportional to square of angular velocity of Earth. Like we know that acceleration due to gravity at an angle theta, we can find out by using this equation g naught minus r omega square into cos square theta. And at equator, we can say that at equator, the value of this theta is equal to 0. So the value of acceleration due to gravity at equator is g naught minus r omega square into cos 0 is nothing but 1. So take it as equation number 1. And if you are writing the same equation at pole, the value of this theta is 90 degree. So this cos 90 is going to be 0. So the value of acceleration due to gravity at pole will be equal to g naught. So if you are going for acceleration due to gravity at pole minus acceleration due to gravity at equator, means if you are going for equation number 2 minus equation number 1, this g naught and g naught get cancelled and you will get the answer is equal to r omega square. So we can write this is directly proportional to the value of omega square. So that's why we can say that this assertion is correct. The reason for it is given that the value of acceleration due to gravity is minimum at equator and maximum at pole. This is also correct, but it is not giving the correct explanation.